Hey there, everyone. This is Bob Martin, the RCSubGuy with the NautilusDryDocks.com, and this is the latest YouTube Live presentation for you guys on the wonderful hobby of RC submarines. Thank you for joining me. I started a couple minutes early. We got a couple people joining in. Thanks for joining me. Gonna have an exciting time here. Had a couple people reach out with some topics that they would like me to cover. There is a chat window in here that you guys can reach out through if you've got any questions. I would love to answer your questions to the best of my ability. Here we are, April 18th. This is a Thursday at 7 p.m. Eastern Time. Let's start talking about some RC stub stuff. So first off, a little update on myself. As some of you guys may know, I've had some health issues, and I'm glad to say that they, for at least the time being, have been rectified. I was diagnosed with appendicular cancer at the beginning of January, so that was exciting. Fortunately, I made a little bit of a donation to the cause in part of my small intestine, my large intestine, some liver, and part of my abdominal wall, and that paid for a clear bill of health from my doctor. So, right on. I go back in September back to Houston to MD Anderson, which is an awesome place if anybody is going through this terrible disease. I highly recommend MD Anderson in Houston, Texas. But that means that we can get on with talking about RC subs without having to worry about any of this other stuff. So, general update. Have not made massive amounts of progress. Obviously, I'm still getting back on my feet. I'm recovering from 3 months worth of backlog at my real daytime job. But I am happy to say, had a couple of little projects that got finished up and shipped out to customers. I got the video up. There was a little Nautilus display model that you can take a look at there. I'm working on a really cool 48 scale German Type 7 submarine project, and this will be a quite involved weathering project. If you guys are interested, take a look for that video coming up here in the coming weeks. We're going to be using a few techniques that are not exceptionally common. You're talking about painting a submarine, so take a look for that coming very soon. So, without any further ado, there were a couple of questions that were posed to me through Facebook Messenger. By all means, if you guys are interested, hit up my Facebook page. That's the Nautilus Drops. If you search for it, you can message me there. I got pictures and updates that typically come through that platform. Two particular questions. One was pertaining to pre-operation and post-operation maintenance of your watertight cylinder. So we're going to talk about that. And the second one is a sort of a bigger topic, and that is talking about successfully trimming out your submarine. So let's start on that topic, shall we? I'm going to put my camera down here and sit down because I'm lazy. There we go. Much better. If you guys visit my website, rc-submarine.com or the NautilusDryDocks.com, if you go to my blog section, I have actually done up a blog called 3 Simple Rules for a Perfectly Trimmed Submarine. 3 simple rules for a perfectly trimmed submarine. We're going to go through these one at a time. Let's talk about the kinds of things that you're going to need when you trim out your submarine, okay? One of the things that you are going to need is ballast of some kind. And what I really recommend are lead pellets or steel pellets. And they're, like 1/8 of an inch diameter. You can get them. Typically, they're used to load up like shotgun shells and that kind of thing. And they come in probably like a 10-pound little bag So that'll actually get you a long way, and they're really, really inexpensive. And the beauty of utilizing them is that they conform beautifully to the contour of your boat. So you can lay them in the base and the keel of your boat, and then coat them with resin, with epoxy, with glue, with anything that you've got there, and that'll adhere them into place. Other things that I like to use, self-adhesive wheel weights for tires, vehicle tires. I sell those on my website at nautilusdrydocks.com. If you want, you can get them yourself. I don't care where you get them from. They're really cool. 1/4 inch or 1/2 ounce little cubes, little squares, and they've got two-sided tape on them, and you just stick them to the bottom of your boat. The other thing that I like to use are actually duck decoy weights, and you could probably get these at like a store like Bass Pro Shops or something like that, but for lack of a better term, they're long strips of lead. And you can cut them easily with, some side cutters, like wire cutters and that kind of thing. So those are kind of the three main weight sources, but you can use anything. You can use nuts, bolts, pennies, anything that you've got. You're looking for weight and something that will do well in the wet. The other thing that you're looking, I lost you guys. I'm sorry about that. The other thing that you are looking to grab is closed cell insulation foam. And let me see if I can find some for you. I'll be right back. Don't go anywhere. I'm back. This is what it looks like. This is 1 inch thickness. Comes typically in 1 inch or 2 inch thicknesses, 4x8 sheets. If you go to your local home improvement store, you can sometimes get the handy panels, 2 foot by 4 foot sheets, super inexpensive, but it's stiff, it's hard. Do not use like pool noodles or that big like chunky styrofoam stuff that comes when you buy something from China and it makes a mess of your floor. Don't use that. The closed cell form is rigid. So when you dive your boat, water pressure will not compress this foam. If the foam compresses, you lose buoyancy. So this becomes an exponential issue. The deeper you go, the less buoyancy you have, which means the deeper you go, which means the less buoyancy you have, and you end up on the bottom. So for heaven's sakes, do not use that like nasty, soft, mushy, ball-like stuff, and please, and I've seen it before, don't use pool noodles. Please don't use pool noodles. That's just ridiculous. This stuff cuts nice and easily with a utility knife, with a hobby knife. You can cut it to almost any shape that you want, and you can actually sand it if you would like. Don't use paint on it though, like enamel paint. If you do use paint on it, use a latex base or like acrylic based paint. Otherwise it'll eat into this and it'll turn into a big goopy, nasty mess. So we got weight and we've got foam. Last thing that you're gonna need is something to adhere the foam with. So you're gonna need like some two-sided tape or some silicone, something like that to glue it down with. So rule number 1. If you have to make the choice about your cylinder placement, you want to put your cylinder low. Typically what you're going to see is your watertight cylinder is going to have your drive motor centered about the center axis, which conveniently, typically with modern boats, lines up with the center axis of a screw in the back. So you would obviously want to align the center axis of your cylinder with the center axis of the boat. Everything lines up nicely. There's no interference. There's no binding. But if you have the option or need, if you have to make the choice, mount your cylinder low. Typically, reason being, it is much easier to get ballast in a small area than it is to get foam in a small area. Foam is going to go high, lead is going to go low. All right? So if you have to make the choice, cylinder goes low, that'll leave room for your ballast in the bottom and lots of room on the top for foam installation. So, rule number 1, cylinder goes low. If it doesn't go along the center line, if you can. Rule number 2, your foam goes high, the ballast goes low, regardless of how convenient it would be to stick a chunk of lead halfway up the boat or on the upper part of the superstructure. Don't do it. Do not be lazy. Foam goes high, lead, ballast, goes low as possible. So what we're trying to do here is create, in physics terms, a righting moment about the center axis of the boat. Foam is going to pull upwards, weight is going to pull downwards. And the further apart they are, the greater the effect that each one of those forces is going to have to right the boat or to maintain level keel. All right? So weight goes absolutely low in the keel as possible. Foam goes absolutely high as is possible. The last rule, rule number 3, surface trim first, submerged trim section. Now, people may argue, oh, well, you know, I don't do it that way and it works out perfectly fine for me, and that's what works out perfectly well for them. These are my rules. If you don't want to follow them, go find another website to follow. Do your surface trim first and then your submerged trim second, and here is why. When you create your trimming procedure, what you want to do in surface trim is only install foam below surfaced waterline. Do not put anything, for any reason, above that waterline, okay? So as you're going through the trimming procedure, your weight is already in the keel. You're going to continue adding foam below the surface waterline until you float at the proper level surfaced waterline, okay? That done, you flood your ballast tank and your boat is going to do one of two things. It is either going to sink down a little bit lower but remain buoyant, or it is going to sink and hit the bottom of your pool or your test tank. Now, if you're going for a full static submergence where you can statically dive all the way down to the bottom, maybe that's what you want. But what you will do is you'll flood your tank in that particular case to the point where the boat becomes just slightly negatively buoyant. And then you are only going to add foam above the surfaced water line. Okay? So what may help you is to actually scribe that surfaced water line on the inside of your boat with a permanent felt marker or something like that. So you understand where that line is, where that demarcation is between surfaced and submerged trim. So flood the tank, it becomes slightly negatively buoyant. Add your foam above that water line until you achieve negative buoyancy. All right, nice and level, and then you can flood your tank the rest of the way. It's going to sink down to the bottom. You can float it up. Everything will still be nice and level. Now, all of this said, what I recommend for anybody, regardless of experience level, ballast your boat so that it is just ever so slightly positively buoyant. You flood your tank fully, and it'll submerge until just the top of your conning tower is visible above the waterline. And there's a couple of reasons. Number one, it becomes exceptionally easy to drive your boat. At negative or at neutral buoyancy, the boat becomes exceptionally responsive to only the input of your control surfaces. So you do not need to worry about your ballast system overcoming your control surfaces, and it's much easier to maintain a level cruising attitude, periscope depth. Number two, it becomes much safer Because in a situation where you dive and lose radio signal, or if something happens for whatever reason, that boat will eventually float to the surface. Even if it is only 1/4 of 1 ounce positively buoyant, it will eventually emerge from the depths and surface, and you'll be able to find it again. So this is a safety issue. So for those of you who are just starting out in the industry, absolutely, I very much emphatically recommend ballasting your boat slightly positively buoyant. Little bit of forward movement, a little bit of input from your planes, and you'll have beautiful control at whatever depth you would like, but you've got that safety margin built into it, okay? So those are my 3 rules for a perfectly trimmed submarine. Let's review. Cylinder, if needed, low versus high. Second rule, foam always goes high, ballast always goes low. Do not succumb to the temptation of jamming foam or weight wherever is convenient for you to lodge it within your boat. Always foam goes high and the weight goes low. And the third and final rule, surface trim first, submerged trim second. If you do not follow the third rule, what will end up happening is you trim your boat for submerged operation, you go to surface it, and it's going to end up wonky. So you have to add foam below the water line, and then you submerge the boat, and the submerged water line is out. So you correct that, and you emerge, and then you have to correct that again, and you end up with an internal loop of terribleness. So surface trim first, boats above the water, submerged trim second. All right, Bob's 3 rules for a perfectly trimmed submarine. Go to my website, nautilusdrydocks.com. Go to the blog site. Look for in the bottom there's like keywords. Click on trimming. There's 2 articles. One is about counteracting torque-induced roll, and the second one is about perfectly trimmed submarines. All right. I just saw a question come through. Do I take into account your battery weight? Well, you don't need to take into account your battery weight. It's all taken into account when you put your boat in the water. I mean, for heaven's sakes, everything is in there. It's operational. Your battery's in there. It's functional. You can move everything, right? If you trim your boat with everything in it, you don't need to worry about this other stuff. That said, I remember when I first started out, I'm building the boat, and I had nothing to do but ruminate about things inside my brain. I'm going to calculate the weight of each individual component, and then I'm going to calculate the moment that it would have about the center line of the boat based upon its distance from the center line, and I'm going to calculate the weight of the boat above the water line in order to calculate the volume of my ballast tank. I'm like, just bear in mind, this is 50% science and it's 50% art, okay? A lot of the subdrivers that you're going to get off of my website or from a number of other manufacturers are going to be custom built for whatever boat and purpose you are going to be using it in, okay? Do not overthink this process. The big thing is just make sure you got enough ballast tank in there. If you are going to be doing any sort of worrying, fretting, or being concerned about your boat, you want to weigh any components or part of your boat that is above the water line, above the surfaced water line. Okay? That's the only purpose of a ballast tank, is to lift that part up out of the water. It's the only purpose of the ballast tank. Okay? So your ballast tank needs to be able to offset or counteract the weight of the components, parts, and materials that are above the water line. So as a little bonus to this whole exercise, if you have the ability from the outset to make conscious decisions about the thickness or composition of materials that you're building your upper superstructure from, make them as light and thin as possible, okay? The lighter your upper hull is, the smaller your ballast tank can be, the less energy needs to be expended to move water in and out of your ballast tank. All right. So there we go. Trimming your submarine in 15 minutes worth of blathering and talking. So hopefully that helped you. Visit my website, download the article. It walks it through. It's got beautiful pictures. It's absolutely gorgeous. I think I used an OTW upholder as an example in that particular case on how to trim your submarine. Let's move the perspective so you don't get bored. Let's put a boat in. There's the rear end of a German Type 7. Oh, what about the watertight cylinder venting modification that David did on the low pressure blower? The venting modification. So for those of you who are not familiar with this, Dave, that he is referring to, is David Merriman III, godfather of this hobby. He'd been in one of the founding members of it. And really, I would say without him being in this hobby, most of us wouldn't be in it right now. The newest iteration of the watertight cylinder that he's built is incorporates something called the semi-aspirated system, semi-aspirated ballast system. The idea behind it is that the ballast system is vented. Air leaks out, you get some really cool bubbles as you're submerging. It looks completely awesome, and the boat sinks. You hit your switch the other way, and what ends up happening is an air pump. Pumps air from the dry spaces of your watertight compartment into the ballast tank. And it's not much. It doesn't need to be much. Like I told you earlier, it only needs to be like 1/4 of an ounce of water. The difference between negatively buoyant and positively buoyant. So it'll pump air into the ballast tank, the model rises. And then you've got a little snorkel valve. And that looks like, well, this is going to be nasty. You guys aren't going to be able to see this because it's in a package, but it's got a valve right here. So this little arm moves up and down. It's on a float. It's a float valve. So as the model surfaces, that valve opens. And then rather than drawing air from the dry compartment of your boat, it draws air from the surface. Right? So it knows that you're above the surface because that float valve opened. It draws air, equalizes the pressure, blows into the ballast tank, and the boat is brought up to the full surface water line. I don't know if that answered your question. Modifications to Dave's system, maybe not. You need to clarify your particular comment if that didn't answer your question. There is a subsystem that I'll talk about here for a moment, though, and this is the gas backup system. And the idea behind this, really, it was the original ballast system that Dave Merriman and many other people utilized for many, many years, and it was propel or airbrush liquid gas. And what this does is basically goes into your ballast tank, and it becomes part of the ballast linkage. So I told you before that ballast linkage vented the tank. Well, when you blow the tank, so venting is getting rid of the air, blowing is adding air. When you blow the tank, that linkage depresses a little tire valve, and it blows air into the ballast tank. So what that allows you to do is just hit the blow cycle. It burps some air into the ballast tank, and the model surfaces. So you create less of a vacuum in the electronics compartments of your watertight cylinder. And the other benefit is if you've got a leak in your cylinder, for whatever reason, that's why we call it the emergency blow system, this will just blow air into that ballast tank, completely voiding it of all water whatsoever until it surfaces. So that's sort of the SAS ballast system in a nutshell. Let me just check and see if I missed anything in here. How level would it need to, what does it say? Be submerged. How level would it need to be submerged for the AD2? So the AD2 is a pitch controller. I don't know that I fully understand the question, but let's talk about pitch controllers for a second. So the 82 is created by a gentleman by the name of Kevin McLeod up in Canada. Go Canada! I'm a Canadian. Live with it or find another channel. The 82 pitch controller is really cool, and really that's the only thing that it does. It's got three settings, three sensitivity settings: low, medium, and high. I find that high sensitivity is good for the small models. Low sensitivity is great for the big models, and medium is good for either or, depending on your operational preferences. The idea behind it is there's an accelerometer inside, and it detects a change in pitch. You can have it flat, or it'll also detect it sideways. So you've got some mounting options as well. So the movement of the servo that this pitch controller controls is all dependent upon the angle that you mount the pitch controller at inside your watertight cylinder. So, further to that question, when you set up your watertight cylinder, you place it on a perfectly flat surface. Back up, I apologize. Place your boat on a perfectly flat surface, because it could be that your cylinder is sitting at an angle inside your hull, and you want the boat itself to be level. So when your boat is level, mount the pitch controller level, and you'll be able to tell that obviously by the orientation of your control surfaces, such as your rear diplanes. Typical setup for this, by the way, the one that I prefer the most is for the depth of your boat to be controlled via your front diplanes. The rear diplanes are run through the automatic pitch controller. So the idea behind this is your front diplanes command to dive, the boat begins to dive. The pitch controller is like, whoa, 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 what are you doing? We need to level the boat out. So it angles the planes and it makes it level, and the boat stays on an even keel at all times. You can actually run that autonomously. You don't have to have a channel associated to it. You just have to have power, 5-volt power to the pitch controller. If you do have a spare channel, though, what that allows you to do is override the plane. So if you want to do really cool maneuver like a crash dive, you would do something like this, and your whole boat would tip forward at a very steep angle and dive very quickly. Or emergency surface, the same thing. The bow would rise, the stern would drop, and up straight out of the water, doing an eruption out of the water. So that is typically the way that you would have that set up. Although there's other ways of doing it. You could link your front and rear dive planes together and have the 82 control that and have an override. It's really what you prefer. I told you what I like to do. You can do that or not do that. If you have questions, more than happy to talk about that separately or individually. Question, do you have plans to build an Engel boat? No, I'm not Engel. I don't have plans for their boat. If you want plans for Engel boats, you should probably reach out to Engel. That makes sense to me. Probably a good plan. Yeah. I've got plans for a lot of boats, but, realistically, I've got my whole queue filled up with building kits. Some people would say that that's not model building, it's model assembling. That's all fine. That's good. Plans would allow you to obviously build those boats. But I will say, and I've said this before, building an RC submarine is different. It's changing. It's evolving. I am a huge advocate of CAD modeling and 3D printing. At the particular moment right now, I'm printing out a 1/72 Astute HMS Astute submarine on my 3D printer. And, something like that would have taken me weeks and weeks and weeks of work to do. But, it took me like 10 hours to do the CAD file. And I can eat dinner and go for a run or work in the shop while my printer studiously spits out a hull for me. Embrace it or die. That's the way it works, unfortunately. Question. When is Thor's sturgeon going to be available? So I just took possession of Thor's molds for the Sturgeon class submarine, along with the Type 21, as well as master patterns for Oscar II, which is also built by Kevin McLeod. Guys, you just got to bear with me here. I have got a full-time job. I work 50 hours a week at a job that actually pays my bills. So the time that I have allocated to this is fairly small, so I'm moving in baby steps, but fear not, I've made an investment. It cost me a considerable amount of money to get those molds, and they will come into fruition. I am, May 4th through 8th, going to be in Virginia ruminating with His Illustrious Majesty David Merriman III, where he's going to teach me all of the intricate ins and outs of creating parts, molds, hulls, and many other things. So that will help with the whole process, absolutely. I am not going to commit to any timeline. Sorry about that. I think it was Ernie asked that question. You're just going to have to watch and see. It'll keep you coming back to my website. There's a question about those Astute files. Heck yeah. As soon as I get the print to double check it of that Astute complete and some pictures and maybe even a build done up, I will have those CAD files available for download, and they will be fairly inexpensive. So any of you guys who have a 3D printer will be able to download it. It'll be an HMS Astute submarine in 1/96th scale, common scale. But of course you can scale it to whatever you want. You can build it to 1:1 if you got a big enough printer. All right. Any plans to update the scribing on the Oscar? No. Take it or leave it. That's the way it is. Maybe I will. I haven't even looked at it yet. I'm sorry. You'd have to take a look at it once we dig it out. Just bear with me. I'll have pictures, obviously, if and or when the Oscar comes into fruition. If that's something that you're interested in, buy it. And if you don't like the scribing, then don't buy it. That's the way it works. We've been talking a lot, and we did not even get to the second topic that we were hoping to touch on. And that was the pre and post-launch checklist. I'm going to wing this. I should have had this written down. I'm going to start with post-launch, okay? After every time you run your boat, you should be cracking your cylinder open and leaving it cracked to air out the internal compartments. A lot of people will bring it out of the pond. They'll take a look at it and they'll be like, it's great, there's not even a drop of water, and they throw it on the shelf for 3 months. If even a drop of water got in there, what'll end up happening is that moisture will corrode everything inside, including all of the brushes for your electric motors, leads, solders, connections, internal circuit boards. Don't be a lazy ass SOB. Take your cylinder out of your boat, for heaven's sakes, crack it open, vent it out, and leave it that way until you run it next time. This is not rocket science, people. I would say that is probably enough for you. You've had a long day, you're sunburned, you're tired. Pull the cylinder out, crack it open, put it on the shelf, and go have a beer. All right? The important part that we want to talk about is pre-launch checklist. Realistically, what you should be doing every time before you run your boat is checking that cylinder for leaks. So you have a disassembled watertight cylinder in front of you. Visually check every component for issues. Are there any torn, cracked, or otherwise violated pieces of heat shrink that may cause a short circuit? Is there any evidence of overheating? Is there any evidence of corrosion? Become intimately familiar with the internal components of your watertight cylinder and make sure that you check it every single time before you run your boat. Seal up your cylinder. It would not hurt at this particular juncture to apply a little bit of silicone grease to the O-rings that are sealing it. Now, I will make a caveat to that in that the OTW cylinder, as per instructions from the manufacturer, does not recommend the use of lubricants on the O-rings. Reason being is that it will, those seals are actually exposed on the outside. That O-ring is on the outside, so any grease will actually trap particulates, dirt, dust, chunks of this, that, and the other thing. So that is recommended to be run dry. All right. Most other cylinders, though, particularly the ones that seal on the inside face of the watertight cylinder, a little bit of silicone grease goes a long way. Likewise, apply a little bit of silicone grease, either in grease or liquid oil form, to your seals, your linkage seals and your main draft seals. All right, slide that sucker together. Now, if you've built your watertight cylinder properly, you will have some methodology built into it such that you will be able to pressurize the cylinder in order to check for bubbles when you submerge it. Typically what I do with that is very, very simple. You drill a hole in the bulkhead, you put a little brass tube in there, you slip a little bit of like silicone tubing or air hose over it, and that's it. You leave it like that, and it stays like that forever. When you are not testing it, you cap the end of it and simply stow the hose in the cylinder neatly. But to test it, submerge your watertight cylinder, blow into the hose, and look for bubbles. The beauty of this is you have full control over the amount of pressure that you're blowing in, and you can see specifically to the millimeter where a leak is originating from. You can see if it is coming from the sealing face of the bulkhead. You can see if it is coming from a linkage seal. You can see if it is coming from your shaft seal, and you can address it accordingly, versus running your boat, coming back and saying, oh my gosh, my cylinder is half full of water, I guess something is leaking, and doing trial and error and trying to figure it out. I just saw a question there. Can you use a Schrader valve? Yeah, I suppose so. You know, you could hook up like a bicycle tire pump to a Schrader valve, you know, in there and pump it. But I find it so much easier, and it's so much smaller and more compact to simply drill a hole through the bulkhead, install within it a piece of brass tubing, slip on a piece of silicone tube, and then you can just blow into it. You've got full control over it. If you over pressurize, and I've done this, okay, so I am not immune to the ignominy of this particular move. If you over pressurize, you can blow the end cap right off of your watertight cylinder, and then everything is going to get awfully wet. So I don't like the idea of pressurizing with a tire pump. You know, you got much more control over it if you just blow gently in, you know, utilizing your mouth. So there we go. We talked about pre-launch checklist, post-launch checklist. One thing I will mention about post-launch, we can go even a little bit further in there. So after you have everything set up, obviously bench test it before you go to the pond. All right? Box type, watertight cylinder, get out of here. No, go to Europe where you belong. Oh my gosh. Go back to 1976 with the rest of the people that use box-style watertight cylinders. Jeez. I'm just joking. I mean, there's advantages and disadvantages, but not my favorite thing. Let's touch on that. Hey, let's touch on that after I talk about the watertight cylinder. So when we talk about the pre-launch, check your boat on the bench. Turn everything on. Check all of the functionality for your dive planes, for your rudder, for your ballast system. Make sure that it works on the bench. Turn everything off. Go to the pond. Put the boat in the water. Turn everything on. Double check functionality. Rudder, rear dive planes, front dive planes, ballast system. Do a static dive without moving. The last place you want to figure out that you've got an issue is in the middle of the pond, in the middle of a dive. All right? Take the time. It will absolutely pay off in spades. If you're going to have an issue, make it 3 feet from the shore versus 30 feet from the shore in 30 feet of water. All right? So that's it. That's your pre-launch, post-launch checklist. Watertight cylinders. Box-style dry hull versus wet hull. I talked about all sorts of different watertight cylinders in some of my previous talks. The fundamental difference between them is that a dry hull submarine, the majority of the interior of a submarine remains dry, okay? The advantage to that is that you've got much more room. It's a little bit easier to work on. You've got more room inside to install components. Disadvantages. You need to offset all of the buoyancy of all of that enclosed space with weight. So the resulting boat is going to be significantly heavier than a cylinder type or a wet hull typed boat. The other disadvantage is that typically you have to have about 1,050,000 bolts on the lid of that dry hull to gain access. With a wet hull or a cylinder style submarine, you pop off the cap with your finger or a screwdriver. It takes all of 3.5 seconds and you've got access to the interior. With a dry hull boat, it could potentially take you 2, 3, 4, 5 minutes of undoing screws. To put that back on, you need to really make sure that you've got even pressure across the entire surface of the boat. So you've got to put all of the bolt heads down lightly, and then you've got to go back around again, torque them down a little bit more. You've got to take a look, if you've got a clear lid, to make sure that the compression of the seal is equal across all surfaces. If you do not, you have to guess. Maybe you've got an aluminum lid on there. Maybe I've got equal pressure across all surfaces of that seal. I really hate to bash it, and I'm sorry if I'm coming across that way, but realistically, that's really how people were building boats back in the 1970s before this idea of a separate watertight cylinder was introduced. When you talk about a watertight cylinder, there's a couple of advantages that you've got in there. Let's talk about disadvantages first. Number one is room. You don't have a lot in there, and you've got a cylindrical surface trying to install rectangular pieces. So you've got wasted room inside. It's difficult sometimes to fit everything inside depending on the size of your watertight cylinder. Advantages, though. The only buoyancy that you need to offset is the buoyancy of the cylinder itself. And in my experience, typically the weight of the cylinder is roughly equal to the buoyancy of the cylinder. So you've got a roughly negative situation in place. So when you're adding foam up above and weight below, all you're doing is creating a riding moment about that watertight cylinder. The other advantage, although I don't see this, and this is like super interesting to me, you can, in theory, transfer those watertight cylinders from boat to boat to boat. They are exceptionally expensive. Remote-controlled submarines are a very expensive hobby to get into. And the expensive part is your cylinder. You know, to properly set up a watertight cylinder could run you $800, $900 if you got a lot of toys inside in terms of, like depth controllers and pitch controllers and maybe like a soundboard and all, like 4 different servos and all of that kind of stuff. So if you can transfer that from boat to boat, to get a new boat could cost you just a few $100s versus a few $1,000s at the outset. But what I find really, a lot of people just buy a separate cylinder for each boat. And honestly, this does make sense because each boat's, weight above the surface water line is different. So the size of your ballast tank is going to be a little bit different, and you might want to have a small boat and a large boat. So you need a large cylinder and a small cylinder. So it's all kind of making sense in that particular sense. Engineering of wet hull cylinder is much more probably than dry hull submarine. Dry hull submarine, you're just creating a dry spot. You just need a flat surface with some bolt holes and a seal. versus having to engineer tolerances and O-ring pressures and all of these other stuff. With a watertight cylinder, which is why watertight cylinder sails are so awesome. Thanks, everyone. So yeah, that is wet hull versus dry hulled submarines. Let's see here. I thought there was a question in here. 3/8, yeah, sure. Torpedoes. Ooh, that could be like a whole discussion unto itself. But let's take a couple minutes and then we'll sign off, okay? Torpedoes. Final topic, unless you guys come up with a really cool topic, in which case I could probably continue talking all night. Torpedoes. Really, there are probably two different propulsion methodologies for torpedoes. You have got gas-propelled torpedoes and you've got electric-propelled torpedoes. Gas-propelled torpedoes have been around for like forever. I think some of the first systems came out in like the 1980s. Like I think 32nd Parallel I think had a watertight, or sorry, a torpedo system that came out. Was using like air AC, like Freon or something for propulsion. Some of you older guys might remember how all this went. But the theory behind it is you got a hollow torpedo, and you fill it up with compressed gas, and you've got a seal on the back with like a little nozzle that comes out of the back, and you launch the torpedo, the gas gets expelled out of the back, and away it goes. The trick with that I find is maintaining a positive seal on the back. I blame that all on you guys. That was not my fault. All right. Torpedoes, nozzle, ejects, bubble stream, very cool for torpedoes, all right? Like I said, the big issue is that seal on the back. I've seen a lot of people pressure up the torpedo, put it in the boat, and it just sits there and it bubbles and it hisses, and by the time they go to launch it, it like oozes out of the nose of their boat. I mean, that said, obviously they work really, really well, and I've used them. The trick is engineering your nozzle size to the correct orifice. I don't remember if I've got video of it, but I've certainly talked about it in some of my videos. You can go back and take a look at some of my past YouTube videos. If you don't get that nozzle size correct, your torpedoes turn into missiles. I remember some of my first tests. The torpedo launched, dove, hit the bottom of my pool, went straight up, flew out of my pool, hit the top of my pool cage, and then landed back in the pool. So you need to make a smaller nozzle with less pressure coming out on those particular weapons. Advantage to that, it is much easier to create weapons of different scales. So that particular scale that I built in was 32nd scale. So you've got like a I'm gonna guess like a 5/8 inch diameter weapon. Here's one right here, 32nd scale. This is solid metal, but it's the right size. All right, so you've got considerable volume in here, lots of room to work with and that kind of thing. But it can go all the way down to 72nd scale, and David Merriman had an exceptionally cool torpedo system for 72nd scale models. And for those of you who are going to ask, before you type it in, don't do it. No, they're not available. And there are many, many reasons behind it. Number one, they're exceptionally hard, difficult, and labor intensive and expensive to manufacture. So if you paid a person what it was worth to manufacture it, you would scream, yell, stomp your feet, and you wouldn't buy them in the first place. Second of all, they are temperamental. Gas-powered torpedoes do not tend to run straight and true. They will typically run, they'll hook to one direction or the other, dive or surface. So they're a little bit temperamental in that regard. But like I said, flexibility, you've got that massive range of scales. Electric torpedoes, there was really two methodologies that are sort of being explored right now, and I'm looking at both of them. With the Type 21, you can see it like way in the background of my shop. Well, let's take a look at it. It's just beautiful. We should pause and admire. That's 30th scale, so 32nd scale torpedo. That particular boat is going to have the same size torpedo as that one over there, and it is going to utilize battery-powered. Oh, look at my chest. That'd be exciting. Battery-powered torpedoes with a timer. So you launch it. As soon as it knows that it's launched, the timer activates. The torpedo runs straight and true for 5 seconds and then stops. You grab the torpedo, shove it back in the torpedo tube, go back out again, and do it all over again. You can do that because you got a 30-second scale torpedo with lots of room inside for lithium polymer batteries, a timer module, a reed switch, motor, wires, and all of the mounting bulkheads inside. The other methodology that was really kind of pioneered by a few individuals, but Dan Catcher was probably one that did it most successfully initially. So Dan Catcher up in Vancouver, shout out to you, dude. He and I worked together, and I've explored this option, and I'll probably be doing this functionality for 48th scale weapons. And this is a super capacitor. It sounds so cool. It's a super capacitor. It's not just a capacitor. The idea behind this is you charge the weapon utilizing a battery. It takes about 10 seconds. Shove it in the tube quickly. Run your boat out quickly and fire your weapon quickly. Reason being, supercapacitors do not hold their charge for exceptionally long periods of time. So if you go out and like patrol for 15 minutes, you could have a bit of a droopy firing of your weapon. But the idea behind it is exceptionally simple. You got a supercapacitor tied to a reed switch, tied to a motor. So you fire the weapon, reed switch activates, power goes to the motor, it goes out till the supercapacitor is exhausted. That's it. It dies after 5 to 10 seconds of runtime, depending on the size of your weapon. You retrieve it, charge it, shove it back in. There is room for that in a 48th scale weapon, and potentially, if you were really talented, as small as 72nd scale. So that is the various technical differentiation or different methodologies employed for operational torpedoes. This boat is going to have ideally 6 operational torpedo tubes, 6 operational torpedoes fired in sequence from a single channel. And we'll get that in play a little bit later. But to give you a little hint, it's leveraging Kevin MacLeod's awesome torpedo control module that just simply plugs into your receiver. Someone asked about a torpedo kit. Guys, like I told you, I got so much going on right now. Realistically, what'll probably end up happening is I'll sell the components and you guys can build them yourself. I'll sell the 3D printed housing, like the torpedo bodies, the motors. I'll give you some instructions and I'll wish you good luck. That's what's going to end up happening. I'm not going to sell ready-made torpedo kits. There is a certain degree of liability involved with them, particularly when you start talking about supercapacitors, because the cool thing about them is if you overcharge them, they explode. Yeah, that's exciting. I'm sure all sorts of lawyers would be excited about that kind of thing. So hey, if you want to try that yourself, kudos to you. Good luck. Please don't blow your fingers off. And I did not tell you to try it. It was somebody else. There's a question, could you inductively charge it? I mean, dude, you could do whatever the heck you wanted. You could slip your torpedo in there. You could have leads on the, the outside casing of the torpedo that rubbed against the contact on the outside of the torpedo. Yeah, anything you want to do. If you can figure it out, more power to you. If you want my help, with input, I'd be more than happy to help engineer that kind of thing. But time is time and money's money, and if I had lots of the latter, I could do lots for you guys. So hey, if you want to donate to the Bob Martin Retirement Fund so I can focus full time on the weapons, torpedoes, RC submarines, I'm here for you. You can PayPal me the money to payments@nautilusdrydocks.com anytime. But hey, on that topic, and why am I fuzzy? It's like I'm in the middle of a foggy field. Last thing, before I let all of you guys go, this is really important, don't go anywhere. It's much better, I had a dirty lens. Why didn't you guys say anything? I got a raffle going on right now. It's on the homepage of my website. We got a countdown going to May 2nd. This is a raffle to support the American Cancer Society. Guys, this is really important, and this is a way more prevalent disease than probably most people realize. Many of you, if you're not going through this yourself or have gone through it yourself, know somebody that has gone through it. This is super important. I've gone through it. I had appendicular cancer, which was my whole issue before. Like I said, had to sacrifice a large portion of my inner workings to get that odyssey figured out. But the cool thing is, not only are you going to be donating, but you actually get something at the end. This raffle is for a complete kit for a Ravel Type 9 model submarine. Comes with the kit, the watertight cylinder, the radio, the receiver, the pitch controller, the battery, everything is there to get you going. So if you're looking to get into the hobby, a $20 investment is pretty small. And even if you don't win, it went to a superb cause. I'm going to clue you guys in, you 27 people who are here right now. If you buy a ticket, not only do you get entered for the draw for the Type 9 kit, but I am going to have a secondary drawing for a very cool prize as well, oriented to RC submarines. So even if you don't win the big prize, you may win something smaller. Totally worth it. Go to my website, nautilusdrydocks.com, right on the homepage. Click on the link that's there. It's got a countdown timer. Buy as many raffle tickets as you can afford. Tell your friends, tell your family. Get that bought. Help us lick this terrible disease. I'm going to let you go. I'm tired. It's the Easter long weekend. Everybody have an awesome time. Don't eat too much chocolate. And if you do, don't tell anybody about it. I am Bob Martin, the RC sub guy with the nautilusdrydocks.com.